Okay, I think this is working now. Let me just check. Yep. All right, so welcome back to the help sessions for week 10. This is the night form of run. I've done one of these before. There is a link in the YouTube chat bar, and that will allow you to ask questions in the Hangouts. So if you check that out, you can access that. All right, so what we're mostly going to go through today is going to be the assignment stuff. Josh isn't here today also, I thought I'd mention. Yeah, hopefully you can hear me all right. All right, so one thing that I wanted to start off with in terms of the assignment was just how people are initializing their structs. So when we have a struct, let's say struct dog, and let's say my dog has a variable int age, and it also has a character to indicate, I don't know, its type. Okay, so then in my program, I'm going to create two of these dogs. So I've got my int main, and then as we know, this is the type. I might actually go over that again after this, but we use struct dog just like we would use an int. This is the type. I know it has a space in it, so it gets a bit confusing, but the whole thing is a type. So you can think of it as an int or a car or whatever. It can do everything that a normal type can do, except for it's our own type. All right, so we've got struct dog, and we're going to make a variable called, let's say, D1. Now we can initialize this using equals, curly brace. For the age, it has to be an int. So let's say we initialize the age to 11. Now for the character, we could put a number because cars can hold a number, but cars are also specifically designed so that they can hold an ASCII character. So if we want to specify a character literal, we use two single quotes and then put the character in between. So for example, A or B. So I could put A here, and that would initialize it to 11 and the letter A. Just remember, this A is still just a number when it's stored in memory. So if you look up the ASCII table, it's still a number. And this is why I still can initialize a car to a number. Okay. However, if I want a specific character, so for example, the letter A, I need to put it in the single quotes. A character. So if I do another example, struct dog D2, then I can have 21, and let's say it's type B. And I probably should put some semicolons there. Okay, so just be aware of that if you're going to if you're going to use a character at all as a character literal, you need to use these single quotes. If you're going to have a string, you use double quotes. So, for example, but a single character is this. And all this will do is actually turn it into its numerical value. So if we grab the ASCII table, give me a second. if we get the ASCII table up, oops, I lost it. If we get the ASCII table up, we can say A is the number 65 in decimal. So the other thing I could do would be to put a 65 here. And then if I printed out this type, I would actually, as a character, so if I use %C, I would get the letter A. However, 65 is not very good for documentation and for someone reading it, so A would be preferable. Okay. If you do something like this, then the compiler is likely to yell at you because there is no variable called A. A is undefined. However, if I did something like car A equals C, then the character here would actually be a C because the variable is A. And that would be legal, but this would be pointless. So there's no need to do that. So unless you've got a variable here, then the A here would cause a compile error. One thing that will not cause a compile error is a 1. But let's say you wanted the character 1. This isn't going to give you the character 1. Okay? If we want the character 1, like the letter, we need to still use it as a quote, because if we use the number 1, when we print the character out, we'll get some control character. Okay, so that was the first thing. All right, let me have a look. If you've got any questions also, just put them in the chats. If you want to join the Hangout, click the link in the chat bar. And just post your questions as you go or speak. It's up to you. Sorry, I didn't find it. Okay, so all right. So we already went over in the short video I gave you how to dynamically allocate the array of structs. However, I'm still seeing people doing it wrong. If you do something like struct dog D1 and then put say 12 here and then say malloc, this is not really going to work because you've allocated an array not dynamically, so you can't do that. The other thing that I've seen people do, which is one thing that I want to go over, so let's say you've got a couple of variables. No, that's fine. So just be careful with struct. I just want to quickly, so in our classes, we started off looking at basic types. We also started looking at functions that were already defined. And we also looked at libraries, I should actually write one, standard IO, etc. So in this class, we have gone from using ones that are already defined to using types that we're defining. So So for example, originally we were using just functions that we had access to, and then we created our own. We originally were only using the standard libraries, and then we started creating our own. It's the same with the types, we create our own. You need to treat this as its own type. You can't separate these two words out, okay? And you should use them exactly as you have been for these. Same with complex add, you use it exactly the same as you have for these, and same with these, except for this one, you need to put in quotes. That's the only difference. Okay, let me have a look at what we've got. Okay. Okay. Okay, super. All right. So the next thing is with our functions. So with our functions, let's say we have a function that passes a struct pointer that's been allocated. So let's go back up and use our dog example. Just give me a second. Delete all this. Okay, so we've got our dog, and I want an array of dogs. Okay, so I'm going to create an array of, sorry. What I'm going to do is create an array of dogs dynamically of a particular length. So I'm going to define that. As being 2. Oh, yeah, 2. So I've got struct dog. My variable is called dogs. Now, because I'm dynamically allocating this, this is going to be a pointer. And then we just use what we've used in the past, which is malloc. Oops. Got struct dog star malloc. Then, as you should know, we then have size of struct dog, because we want this many dogs, times by the number. So this is going to be using our macro. Okay, so now we've got an array of dogs, which is of length 2, because 2 here and 2 times this. So now I can use this normally. So now what I want to do is create another function. Ignore the prototype, but you need to add that. So what I'm going to have is void initialize dog, initialize d, and then I'm going to have my struct dog star, and let's call it d. And I also need to know the n value, so how many there are. So what I'm going to do, oh no, that's fine. So I'm going to have this as an int, and I'm going to call it num. Okay. So what I want to do here is initialize my dogs to, let's say, I want to initialize them all so they're of 0 age and they're all of type A, let's say. So what I need to do in here, anytime I need to go through a whole array, I need a loop. So I'm going to create a loop. using a for loop. So I want to do this loop for all my dogs. So I less than num, and then I plus plus. Now, because this is an array, we can treat it exactly like an array. If you want to, you can do it with pointer arithmetic, but just be careful because it is a little bit more complex. But you can use this as an array. So you can go d I dot, what have we got? Age equals 0, and d I dot type equals w, let's say. So let's have a look at this. So what I might do, then we've got to call our function. So this is a void function, so it can't return anything. So we can't say it equals something or becomes something. It's int d. Our struct, now this is something that a lot of people just try and guess how to pass variables when they're dealing with pointers. The easy way to check if you're sending the right thing, this type here and this type here are exactly the same. So we can just pass this variable as it is. If it is different, so let's say this was 2 stars, then I would have to pass the address in. Okay. If it had no stars, then I would need to dereference it, and then I could only talk about 1 dog. But in this case, we need an array, and this is already an array. The second variable is our int num, and we know that's 2, so we'll use our macro. Okay, so now we call that function. So what we're going to do, how much room have I got? Not much. I might make this smaller. Can you still see that? All right, cool. All right, so we start here and we create, we create our pointer called dogs. It points to some memory, which are of type struct dog. Okay. As I said before, do not get confused. Dog is not the type. It is struct dog. And then inside here, it has a couple of variables. So it has an int and a car, and this one has a car and an int because I want to go backwards. Okay, so we've got the first one here and the second one here, and this is dynamically allocated. We've got a pointer to that, which is of type struct dog star, because it's a pointer, and it's pointing to the first memory address of these structs. Okay. What's in each of these at the moment, we don't know. Okay, so we can just represent that with a question mark if we wanted. All right, so now we've created that. We then have this here. Now, this is a pointer. So we now have a new variable in our function. So this is our function called init a, and it is passing the pointer. to the value here, which is pointing here. So when this, so we're up to here right now. So we've just called this function and it's passing these things in. So before the function starts, it creates these variables. So we've got a variable D and it's of type struct dog star. And we've got another variable called num. It's of type int. Now, sorry. Now from this, we want to, from this, we pass this value. So now we have a pointer here to the same place. So this is main, sorry. And we also pass the value 2 in. So now num is 2. Then we create another variable called I, which you should all be very familiar with. And then from here, I equals 0. So we say d0.age equals 0. So d, 0th index, this is 0th index, equals 0. So now this equals 0. We then say d0.type equals w. So now this equals a w. Then we increment I, as you've all seen in a for loop. And now it equals 1. And then we go through the for loop again. So we've got d1.age equals 0. And then we say d1.type equals w. Okay. Is there any questions about that for those that are watching? Well, I have to look what else there is. Just say yes or type yes if it's all good. So I get some feedback. Good. All right. So next thing I want.
Matt.
Yo.
Yeah, I have a question.
Yeah, let me just turn the volume down. You're very loud.
Oh, sorry.
No, it's my fault. My headphones are up too high. Yep.
Since here we have used for loops.
Yep.
And during which I is used as the index.
Yep.
And I gets incremented. Instead of that,
Yep.
can we dereference the variable d and
Yes.
increment by 1?
Yes.
So that
yes, of course.
It is the same thing, right?
It is the same thing.
Yeah.
That's perfectly fine. However, you will need to use a different notation. Remember, if you're using a pointer, you need to use this rather than this. Yeah. But yes, you can. And if you do pointer arithmetic, it is actually faster. So go ahead. It's a lot better. This is the easier way to do it.
Yeah.
But that's perfectly fine. All right. Let me have a look where we're at now. So in the first task, let me grab the sheet up. Where's my word? Okay. Sorry. Sorry, it's not very prepared. Where is it? Here we go. Cool. All right, I'm just getting it started up. Actually, I probably just should get that from LMS. All right. So I think this is very similar to your initialization one. So that should help there. Let me get the assignment up. Here we go. Cool. I've still got the draft version. That's okay. All right. So just one other thing to remind you, that there is the stages. Try and do it stage by stage so that you don't get stuck. With that, you can submit multiple files. So if you get one working and you don't get the other, you can still submit both. And that's perfectly fine. All right. So we've printed our name, done that. All right. So now let's have a look at initializing the board. Now, from what I've seen from people's code, they haven't had too much difficulty with this. All right. Why can't I move? All right. So in this, I'm not going to give any code, but when we print the board out, we have something that looks like this. We then have 3 dashes, a line, 3 dashes, a line, 3 dashes, a line. These lines aren't very straight. 3 dashes, a line, 3 dashes, a line, and so on. We also have the numbers up the top. So 1, 2, 3, 4, 5, 6, 7. And we also have the numbers down the side. 1, 2, 3, 4, 5, 6, 7. Now there's a gap between each one of these. So it should look something like this. So when we are doing this, we basically need a for loop inside of for loop because we're looking at multi-dimensions. So the outer for loop is going to go through this way, so the whole thing, and the inner for loop is going to go through each one of these lines. Okay, you've got the length, so you should know how many times you have to go across. Don't forget that when you're doing printing or looking for stuff, look for patterns. So in this, we can see that every time we go around the loop, so I think I missed a dot, dot. Yeah, so there should be one there. So when printing, the first thing that's constant is this 1s to 7. So you can just print that out straight away. And same with this first line, we can print that out straight away. But then we have this 1, 2, 3, 4, 5, 6, 7. Now, the good thing is that you've got a loop here. So these values could be I or I plus 1. So we can print these quite easily. So in your inside loop, in your inside loop, the thing that repeats is basically you've got this that repeats. No, this, sorry. So you've got something and then a line, something and then a line, something and then a line. Something and then a line. So before you start your loop, your inside loop, you probably should print the number and then a line, and then inside your loop, print whatever character goes here, a space, and a line. Then when you get to the end of your loop, and before you start the next loop, this is constant, so you can print that out every time you get to the end. Okay? So these two things can be printed every time you loop, but in your inside loop, the thing that repeats is going to be these 4 characters here. Now, one thing that you need to be wary of is pointing at null and trying to access something at null. So every time we visit one of these, well, every second one of these, we need to check if it's a player's piece. So let's just go down here. If I do something like, let's say printf percent, let's say, where am I? Let's say space %c space line, and then I do checkerboard I j, and I do something like symbols, sorry. The problem with this is that if this here is null, so this position is actually null, you will segfault because you're trying to access symbols in something that is null. So you should always, when you know that there's going to be nulls, and generally good practice, you should always check for nulls anyway, before you print anything, check if it's null. And this goes throughout your program. So what you should be doing each time before you print a piece is checking if something, you can work that out, is not null. Then you would do your logic to print. Now, this also is still missing something because you've also got the king symbol. You should be able to check that because you've got a variable in here, or inside the type called king. So you can check if you need to use this one or if you need to use the king symbol. So I think that's, yeah, so this is really important that you check that this is not null before you try and access things from it. So it goes the same if I was up here with my dogs, and let's say I didn't initialize this, and I said dogs 0 dog 0 equals null. Then I try and go printf %d dog 0 dot age. It's going to segfault because dog 0 is null, so I can't access that age. Okay, so if you don't know if it's null, you should always check before printing it. So does anyone else need any more clarification on the printing? I've lost the YouTube. Where is it? Does that make sense? Or is there some more clarification needed? I don't want to give too much away for that part, but that's something that you really need to be aware of is the null, and that'll avoid segfaults. And that goes with any pointer as well, because pointers can point to null, meaning it points to nothing. Is there any questions up further on that? I can't see the thing. Just say yes if it's all good. Cool. All right. So this is the printing the board. And then we've got also initializing the board. Now, the other thing that I'll mention is the good thing about the printing the board is that it's done early, so you can test it and play around with it until you get it to work. Because also you've got to worry about the aligning it, making sure everything aligns. So the other function that's part of the first part, I'm pretty sure that's the first part, yeah, is the initializing the board. Now, from what I've seen, most people have done this pretty much correctly. But this one we're going to use pointer arithmetic. You don't actually have to, but I think we specified that you should, and that just tests that we know that you understand how to use pointer arithmetic. Let me check the assignment sheet. Where is it? Okay. So one thing that I do want to show is, give me a second. All right. That. Okay, so testing if the number is odd or even. So there's a couple of ways you can go about this. Sorry, I keep losing the chat window. All right. So just a recap on some maths. So an odd number is things like 1, 3, 5, 7. And an even number is things like 2, 4, 6, 8, and so on. For our case, we can also include 0 in there. Now, there's a couple of ways in C to check if a number's odd or even. The first way involves the mod operator. So this operator is the mod operator or remainder. So this gives the remainder of some kind of a division. So if I have 3 mod 2, the answer would be 1, because we have 1 and 1 remainder. If I have 1 mod 2, the answer would be 1. If I have 5 mod 2, the answer would be 1. And if I have 7 mod 2, the answer would be also 1, because we have 3 and 1 remainder. So we just get the remainder. Here we'd have 2 and 1 remainder. Here we'd have 1 and 1 remainder. And here we'd have 0 and 1 remainder. Okay, so just simple division. Now you can see when I use 2, so let's have a look. So just as another example, if I had 22 mod 10, the answer would be 2. Okay? Because we'd have 2 and 2 remainders. All right, so now here we have all these and they give 1, and then we have 0 mod 2 equals 0, 2 mod 2 equals 0, 4 mod 2 equals 0, 6 mod 2 equals 0. So we can see if the numbers are odd, the number mod 2 will give a 1, and if they're even, the number mod 2 will give a 0. Okay, so what we can do if we want to check if the numbers, I'm going to do this the bad way first. So let's say int a, and then I scanf from the user a number. And from this, I then go if a mod 2 equals 1. Now, we don't actually need that equals 1, but I'm going to leave it there for now. I can then say printf num is odd. Now, I also said we don't actually need this equals 1, and the reason is because if it was even, it would return a 0, and so this would equate to being false. Where if it's odd, it will equate to being true. Okay, so if we want to test if it was even, we could do equals 0 and then say it's even, or we could say not. So we turn that 1 into that 0 into a 1. But that's one way to do it. The second way to check if it's odd or even, the second simple way to check if it's odd or even, is to use bitwise operators. So with bitwise operators, let's just get rid of this stuff. Okay, so I got a question about mod. Mod will work for all numbers except for floating point numbers. If you want to do a floating point mod, which we actually did in one of the labs, you need to use a function for that, which is fmod, and that's in the math library. So all the numbers have to be non-floating point. So you could use a car. So non-floating point includes car, short, int, long, but you can't use double or float. Okay. These are all integers, and these are all what you call real. Okay, so a car is an integer, a short is an integer, an int is an integer, and a long is an integer in terms of mathematics, and these are all real numbers. So all integers can be used for mod, but you can't use them for real. All right, so next thing's next. If we have a look at some of these numbers in binary, so let's look at 1 in binary, it's just 0, 0, 1. 3 in binary is 0, 0, 1, 1. 5 in binary is 0, 1, 0, 1. 7 in binary is 1, 1, 1. Then we have a look at these numbers in binary. 0, 0, 0, 0. 2 is 0, 0, 1, 0. 4 is 0, 1, 0, 0. 6 is 0, 1, 0, 0. 8 is 0. Oops, no, it's not. It's 1, 0, 0, 0. Okay, so we can also see another pattern here. If the least significant bit, or the bit most to the right, is a 1, then the number is odd. If the least significant bit is a 0, then the number is even. So given our example we have here, we can do if a and 1. So we AND the number with a 1. We can check if the number is odd. So I'll just go through the maths of that in a sec. So printf odd. Okay, so basically what I'm saying here, we have 0, 0, 0, 1, and we AND it with a 0, 0, 1, which gives us a 1, which is true. So this would be true. So the other way I could write this, but I don't need to, would be equals equals 1. So if I had 3 and I did 0, 0, 0, 1, 1, and I AND it with 1, I get a 1. If I do this and 0, 0, 0, 1, I get a 1 because these are both 1s. Okay. If I try and AND, let's say this one, with 1, this first one and a 0 is a 0. This 0 and a 1 is a 0, and so I always get 0 if it's even. So there's two different techniques you can use for checking if your number is odd or even. Now for a final YouTube video. Okay, so we've got another question here. Yes, okay. So I just had another way of doing it. Now, typically, there is multiple ways to find an odd or an even. However, this would be optimized to A shifting that way, and you're actually doing more work. So you can see already that there's two operations here rather versus one operation. So this is optimized, and actually you'll find that the AND is the fastest way to do it, because AND is I won't confuse you, but it's the quickest way to do it. Multiplication is quite slow. Division is a form of multiplication, so it's also quite slow. Plusing and minusing is faster. Bitwise operations are really fast. So if you are trying to optimize, always go towards bitwise. If you can get rid of times or divide, go for plus or minus if you can. Obviously, things like don't go A plus A plus A to save you from going A times 3. because this is still one operation versus two. So this may be faster, but the compiler will work that out for you. Okay, so another question we have on the other chat is, which one is here? Okay, so if there is a king, what should we display it as? So in your variables, you have a struct, player symbols, and that's symbols I can spell. And you have a car symbol for the normal players, and you have a car king symbol. So you're going to use, this is actually part of the other structure, which is part of the piece. So each piece actually has both of the symbols in their structure. However, there's another variable, so let's chuck that in. We have the checker piece. And one of the variables is king, and there's a couple more, and then we have a pointer to the player symbols. Which is symbols. Now the reason it's a pointer rather than a standard variable is because all of these pieces can all point to the same struct. So you don't need a copy of each of the symbols each time. Rather, each piece just has a pointer to go and grab them when they need them. Okay? So that's why it's a pointer. Now, this king variable will tell you which symbol to use. It will tell you to use this symbol or this symbol, but you have the access to both of them with every checker piece. So just be aware of that. This is pointing to a single, two of them actually, because there's one for the first player and one for the second player. Now in step 3, it tells you to create 2 of these. Okay, so we create 2 of these, and these are the only 2 we ever create. Remember, for each of the checker pieces, it doesn't have its own set of symbols. It's still pointing to these same 2. Now, it also says to initialize these variables. So for the player 1, we have a lowercase o, and then we have a 0, or it could be an O, it's up to you. And then for player 2, we have a little x and a big X. This one is the king, and this one is the king. However, we don't mind. If you want to be creative and change these around, you're welcome to. However, they must make sense. So don't put X here and X here. But if you want to play around and make it a little different, you could do a little a and a big A or something like that. You're welcome to change that. We won't mind, and we won't remove marks for that. So if you want to be a bit creative about these symbols and change them, you can. But the king is the big one, generally. Okay. Does that make sense? All right. Let me have a look. What else is on the assignment sheet? Step 1. All good. Thank you, sir. All right. All right. So once you've got all that, you should be able to print out a board. Once you've got the board, you've got. So the good thing about doing this in stages, and once the board works, you are able to easily debug your code. Because what it means, so when you get to the moving around part, once you can, so let's say you get to the moving part, let's say you have a move function or whatever. If you get stuck and you're not sure what's happening, you can always print that board out. Okay? So you can use that print board to debug your code. And you can use it as often as you like. And that will show you where all the pieces currently are. And this is why we wanted to create it early on. So, for example, if you're moving up the board rather than down the board accidentally, you can see that visually with the print board function. Okay? I will have a short video of the game playing sometime soon. But right now, yes, you can use that once you've got that to start doing stage 2 because you can see what's happening. Does that make sense? All right. What else? Cool. All right. Has anyone got any questions regarding any of them functions? So I'll just go back to the printing and what I was saying about the king, because I think it's a good point. Actually, did I already do? I must have rubbed it off. Okay. So when you are printing your board, make sure you're using the king variable inside your struct to check if it is a king or not. Then, so if that is true, or T, or whatever letter you choose, then you can print out symbols, dot, king symbol I think it is, or something like that. Do not just print out the symbol and don't change the symbols, because if you change the symbols, it changes it for all of them. Remember, it is a pointer to a single thing. Okay, so you need to check this king to see if it is a king. Okay, to start off with, you might want to ignore the king and just print out the symbols to make sure it works, and then add the king in after that. Okay. Is there any other questions regarding the assignment? Let's have a look. see if there's anything else we haven't covered yet. Well, let's try to use. I think that's pretty good. All right, is there any other questions regarding the assignment? I'll just give you a couple of minutes. See if anyone's got any questions. Okay, move place. I'm just going to step 4. Okay. All right, so we're going to have a look at step. Someone's asked about step 4 of the move piece function, so I'm actually just creating everything. Yep, beautiful. All right, give me 2 seconds. I'll get the document up. Okay. So step 4, I don't want to give too much information about, but I will give some. So this is where this will really test your logic, and this is a really important part of the assignment. So I don't want to give too much away, but let's have a look at it. So the first thing is you have a variable called okay, so you have a variable called move flags. So this is similar to when you did the BitLock lab. You had a variable full of flags. So this move flags is whatever type. I'm not going to tell you what type. But let's say it has a collection of variable numbers. The last 4 are your flags. So this flag says something, which it tells you in number 2, and that is that the player cannot move left or up and up. This bit here tells you player cannot move right and up. This one not left and down, and this one not right and down. Okay, so with flags, and like that BitLock example, we need to set these flags. So we can do this using bit shifting. And basically, if it's true, so let's say the player can't move right and up, then all we do is we'd set this one to a 1. And then we go through and check the others. Okay, that's true. Okay, so the player can only move this way. Or there is the case that the player can't move at all. So what this is saying is, let's say we have a checkerboard. And you've got player here, and they're a normal piece, and they're going up the board, okay? Because it's not a king. So what that would mean is we can see that they can move up and left, and they can also move up and right. But because it's a normal piece, they can't move down and left, and they can't move down and right. So what would be set is these two would be set to 1. Okay? And this is what it's basically saying. So then, if I had another piece, let's say another piece here, this one can't move there anymore because one's blocking it. So the only way it can move is up and left. So the only bit that would be 0 is this one. So we know that the piece is going to move here. Okay? So this is the bit flags. Now we'll have a look. I probably should have left that there, but I'll draw it again. Just for the fun of it. So now let's have a look at how to set these bits. So let's draw the board again. I wonder if I can just get it back. Actually, I might do a better job of drawing it, just so it's clearer. That's not what I wanted. Why? So let's say this is my board. I probably haven't got enough there, but whatever. Okay, so this is my board, and let's delete these. Okay, so this. So if we go back and have a look at our structure of our board, we have. Still drawing lines. We still have 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. I can set up and might actually do them all. So it'd be handy to have a full board. Sorry about this. I probably should have done this a bit neater, but oh well. Right, so that's my board. It's nice. Okay. Okay, so this is my board. And we're going to have, who's at the top? Zeros. So we have zeros at the top. These are little zeros and x's at the bottom. Okay, so now what we're going to have a look at is our step 4 of the big piece function. Now, just as we're there, I will also say, if you want, you can join the Hangout link by using the link I'm chucking in the chat. Okay. All right. So, sorry. There's so many things I want to do. All right. So the first thing of number 4 is we're looking at this bit to see if to see if the player can move left and up. So we have this way and up. So we're seeing if they can move that way. All right. So this is quite easy if we're looking at these pieces up here, because these can only move down. So in step 3, if it was one of these players, this would be set to a 1. So we wouldn't have to worry about this one, but we'd have to worry about these two because it can't move up. If it's one of these players, then we would have to worry about it because these ones would have been set to 1 in step 3, but you've still got these set as 0 in step 4. So we know that these ones are the only ones that can move up. Now, let's have a look at, let's say, this piece here. So what we want to know is, firstly, the destination X can't be left because it's out of bounds. So actually, we won't look at that one, we'll look at this one. So for this one here, the destination can't be left because this point here is out of bounds. Okay? If we know the X value of this, so the X value is 1, if we subtract 1 from that, depending on how you've done it, so if X is 0, if you've used the 0 here, then the out of bounds value would be -1. Otherwise, it would be a 0 here. So we can test if this is out of bounds quite easily. So we can just say if X -1, because we're going left, which is -1, equals something. You can work out the something. Okay. Then we would set this to a 1. Okay. So that's A. Okay. So the case that this would be true is only whenever the player is either here, 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 or here. And for going right, it would be here, 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 or here. Because the out of bounds is here and here, and the player can't move more than once. Until you get to the jumping, but we'll get to that. All right. So does that make sense for the first step? Person that asked. I'll get rid of some of this stuff. And this I want to push it away. So if that let me know if that makes sense, and then we'll go up to the B. Yes, does that make sense? Okay. So B is looking if Y is out of bounds. So once again, we're looking at all these X's. Now, if we're going up, the only out of bounds is going to be right up the top here. Okay? So this will happen when you have a king, or you have, well, it's only going to happen when you have a king, because if they get up here, they can't go up one more place. Okay? So same thing here, except for now we have our dest y variable. So if our destination is out of bounds, and you could actually use a macro here if you wanted, which I'm going to do to make. So if that's out of bounds, then this would get set to a 1 because it can't go any higher. And the same would apply for this one. Now, the next one is C. So C is the destination cannot be reached as it's a player's piece. So let's say we are this piece and we want to move left and up. This is a legal spot, but we've already got our own piece here. So if we look at, so we're going dest y and x minus 1 because we're going left. So if this own piece then this would have to be set as 1 because it can't move left. Now, this is something that you really need to be careful of. So as I said before, if you try and go something like checkerboard dest y x minus 1 player to check if there's a piece there of the same player, and this spot is actually free, you're going to segfault because this is null. Okay, so if it is free, you're going to segfault because you're trying to access player from something that is null. So you should always check first if it's null, and then if it isn't null, then check if it's the player, the right player. Okay, and that is also in red on the document. It was actually going to be removed, but we left it in. Now, so that's that one. So C is the case that can't go because your own piece is in the way. Now D is the most complex one. Now with D, be careful, there is some brackets in the text. Make sure you use them. I think one's actually missing, so I think Josh has fixed that already in the version he's got. I've got the old version. So with this, use the brackets in the text. Okay, the brackets are there to help you know where to group your ands and your ors. Okay, so make sure you use them brackets that are inside the text. Okay, so the last case is so the last case is that you have, let's say, oh, we're going left. So let's say your piece is here, okay? And you have an opponent's piece here. So what we need to check for, we know we possibly could jump this, but the resulting jump would be out of bounds. So this is x minus 2 is out of bounds. So if left and up is the opponent's piece, but x minus 2 is out of bounds, then we can't jump. So we know this is not valid. Okay. The second case is one of two things. So if the opponent is here, but they also have another opponent behind them, we can't jump because there's a piece in the way over here. Now, this could be either the opponent's piece or your own piece. It doesn't really matter. Either way, you can't jump. So what you're checking for here is destination jump, y, and x minus 2 null. Because if it's null, then it means nothing's there and you can jump. Okay? Now, as I said, use the brackets in the text because that will help you write that up, because there's a number of ands and ors in there. Okay? You can actually, if you want to challenge, it can all be done in one line of code too. But that's up to you. All right. Cool, that's clear. All right. Any other questions? Oh. If you've got questions, put them up. If you've got questions about the labs or the quizzes, you can ask that too. I'm not covering any other material. This week's material is all in the lecture notes. It's fairly simple, so there's nothing really to cover there. The lab's also going to be fairly easy this week because I want you to focus on the assignment. This hangout and well, the next one as well will be similar in that, yeah, you need to ask for help because not enough people are showing up. So if you've got questions, bring them up because regarding anything. Yes, so basically, so I've got another question. So they're all very similar. So this one here is left and up. Okay, so with the second one, it's right and up. Now, this here up, B is going to be the same for the second one because we're both looking at up. However, with our going right, we're not looking at x minus 1 and x minus 2. We're now looking at x plus 1 and x plus 2. And then for the third variable, same thing. So now we're looking going down the board. So with this, we've got one other change. So we know that dest y is going up the board. So for these two variables, we're going to be looking at dest y2 because we're going down the board. However, the x will be similar for these as we're going left and right still. So they're kind of a combination of each other altogether. So they'll all look very similar. There'll just be different values for these, and there'll be different variables used depending on which direction you're going. And the good thing is that you can test all this with your printing function. So you can see, does it go in the right direction or not? Is it being limited? So what I would do once you've done all them conditions, I would just print, I would do your board. And don't be afraid to also place your pieces where you'd like them for your testing. So you could have another function just for testing, so you could place your pieces where you like. However, if you've got your board, you could try each piece individually. So let's say I'll try this piece and then print out the move flags. And then I'll try this one and I'll also print out the move flags. And then I'll try this one and print out the move flags. So try every piece and see if the move flags are right for each piece. However, you may need to move your pieces around. So change where they start so that you can see different conditions. Yeah. Where is Google? And don't forget, submit your assignment early because I am looking through them to see where people are making mistakes. And we'll also record when you've first submitted. So submit early and just keep resubmitting. Any other questions or any other things? All right. Well, we might finish it early if there's no questions. Hopefully there's more people next time. I'm a little disappointed to see not that many people showed up, considering the marks of the last assignments. So if you're watching this in post, I'm happy to stick around most times, but if there's no questions, then it makes it difficult. So I encourage you to try and take advantage of the resources you've got. All right. Well, any other questions before I leave? All going all right with the assignment? All right, I may leave it there then. Thank you everyone for coming that came. All right. Why?